Okay, in this assignment, we're dealing a lot with vocabulary and a little bit of stuff that we've been talking about before. So we're going to be talking about when you're in a system and your mistake has been made or an error has happened. And so we're going to be making the distinction between random errors and systematic errors. And so random errors are those errors that are unpredictable and unintentional, and you'll see this a lot in the coming problems, where there'll be a person that makes a mistake, they miscounted or something like this. That's a random, unpredictable, and unintentional error. We would say that's a random error. Systematic errors, that means something's wrong with the system. There's something in the context of where you're working that is not going right, and usually you can fix it, right? Those are the differences between these two. Let's do some examples. Number one, describe possible sources of random and systematic errors in the given measurement. Account of every different meadowlark that visits a 3-acre region over a 2-year period. Choose the correct answer below. Random errors could occur due to not counting some birds and double counting other birds. That looks right. Systematic errors could occur because several meadowlarks could be flying around in the same area at once, making it hard to count them all. That's not something about the system. Systematic errors could occur because some birds that are not meadowlarks could be misidentified. This would be a random error, right? Misidentifying them. So if something's hard to count them all, that again is a random error. And so random errors could occur because some of the meadowlarks have babies that cannot fly yet. That would be a systematic error, right? Something about the system that creates an incorrect reading. So the answer is A. Describe the possible sources of random and systematic errors in the given measurement. The annual income of 200 people obtained from their tax returns. Choose the correct answer below. Random errors could occur where taxpayers make honest mistakes. That would be unintentional. And unpredictable, right? Or when the income accounts are recorded incorrectly by accident. Systematic errors could occur when dishonest taxpayers report income amounts that are lower than their true amounts. That's right. So dishonest taxpayers are just a part of the system, and we can work towards correcting that. But dishonest taxpayers are a part of the system that creates errors. Number two. It's A. Describe the possible sources of random and systematic errors in the following measurement. Speeds of cars recorded by a police officer using a radar gun. Errors in the speedometers of the cars observed. That's not unpredictable or unreliable. Okay, so errors made by the police force when choosing which officer to check the speeds. No. Errors made by using a radar gun that is incorrectly calibrated and consistently reads high or low. We're looking for random errors. That's not a random error. That looks like a systematic error. Errors made when calibrating the gun. Okay. Errors made by the police officer in recording the speeds, and errors made by the officer in reading the radar gun. So those are just errors that aren't intentional, aren't predictable. It's D, E, and F. Which of the following would be systematic errors in the situation? Select all that apply. Errors in the speedometers of the cars observed. Systematic. Errors made by a police officer known to consistently read the radar gun output higher than the actual value displayed. Okay, so that this officer, who is known to always have this problem, is part of the system that can be corrected, right? A systematic error. Errors made by the police force when choosing which officer to check the speeds? No. Errors caused by the different makes and models of the cars observed? No. And errors occurring when analyzing the speeds? And errors made by the police officer in a radar gun that is known to be malfunctioning. So this whole known again. So yeah, these here, errors occurring when analyzing the speeds, might be a random error, right? So this might be a random error. So yeah, but systematic errors are when you know something about the system that you can correct. And because you know the word known is here is telling you that you know something about the system that's fixable. B and F. A tax auditor reviewing a tax return looks for several kinds of problems, including 1, mistakes made in entering or calculating numbers on the tax return, and 2, places where the taxpayer reported income dishonestly. Discuss whether each problem involves random or systematic errors. Does mistakes made in entering or calculating numbers on the tax return involve random or systematic errors? So we know that this is random, right? It's unintentional and unpredictable. This involves a random error because most taxpayers enter random numbers to hide. No. This involves a random error because unintentional mistakes are predictable and random. I like that. Does places where the taxpayer reported income dishonestly involve random or systematic error? So this is a problem that's rampant throughout the system. This involves a systematic error due to underreporting of income, which is a problem when filing a problem with the system of tax returns. Before taking off, a pilot is supposed to set the aircraft altimeter to the elevation of the airport. A pilot leaves Denver, altitude 5280, with her altimeter set to 2476. Explain how this affects the altimeter readings throughout the flight. This is a random error. Sometimes altimeters set to random altitudes. No. This is a systematic error. All altitude readings will be about 2,804 feet too low. This is a random error. The pilot made an unintentional and unpredictable mistake. Or D, this is a systematic error. The plane will be 7,756 feet too high to land in Denver. So this one may be hard to understand, but this one is a systematic error, right? So before taking off, a pilot is supposed to set the aircraft altimeter to the elevation, right? So this is a problem with the system in that there need to be checks to make sure that the pilot is setting the altimeter to the right elevation of where they're going. So it was certainly unintentional, but it's not unpredictable, right? So it makes sense that you could predict that once in a while a pilot would make this mistake, and so you could fix that, right? That makes it a systematic error. So that the fact that this is fixable makes it a systematic error. So that's the question. Is this fixable? Number 6, find the absolute and relative errors in the following situation. All right, so what's going to happen is you're going to have a true answer. So your true height is 68 inches. The NERV says is 67.3. And so the question is, how far off are you, right? So what you want to do is you want to take the, you can write it like this. So you could say the true height versus the wrong, right? So you can do wrong minus the right answer, right? And so the absolute error, so it's going to be 67.3 minus 68 to indicate that you are negative 0.7 inches below what you said that you were. The relative error is exactly what we would expect. You would then take the wrong minus the right all over the right. So then it would be 67.3 minus 68, and then divided that by 68. Negative 0.010. Negative 0.010, which is about 1%, moving the decimal place. So it's true, well, it's false minus true divided by true. Your bike speedometer reads 23 miles per hour when you're actually traveling at 26 miles per hour. So you are 3 miles per hour lower than what the truth is. That's what the speedometer is reading. And the relative error is going to be 23 minus 26 all over 26. And then you're going around. So 23, 26 divided by 26, and then times 100. It's about 23.08%. How many decimal places? 23.1%. The true price of a gift you purchase by mail order is $18.58. But you're billed for too much. So you would subtract that. 1922 minus 1858. 64 cents. Too much. 0.64. The relative error is, and then you're just going to divide that by the right answer, 1858. So then you do the same thing, divided by 18.58 is about 3%. So it's 0.0344 times 100. Let's go ahead and multiply this times 100 times 100. 3.44%, or how many decimal places? It's 1 decimal place, 3.4%. The actual distance you went is 40.3. 40.6 is what the odometer read, 0.3 miles, and then 0.3 miles over 40.3 times 100. 0.3 times 100 divided by 40.3, 0.74%. How many decimal places? 0.7%. Which of the statements is false? Choose the correct answer below. Difficulty of counting the homeless can lead to undercounts. That's true, because you're going to count less than what there actually are. B, college students being counted both at home and at their schools can cause overcounts, right? You're counting them in more places than they are, so that could be too many. Children of divorced parents being counted in only one household can cause overcounts. No, if you counted them in both households, that could cause overcounts. It's C, that's false. Hope it helps.